Hello everyone, welcome to this third session on magnetostatics. Today we will extend our discussion and we will explore more details about the magnetic field and its applications. So previous classes we have discussed the things about the magnet, how the force lines goes. We have considered the example of antenna as the source of conductor, and we have discussed that there will be various mobile phones located at various locations and it will have some effect from the antenna differently. So now extend our discussion and we will explore it in more detail and we will see the different cases of magnetic field intensity. So last we have derived the BIOT-Savarts law. In BIOT-Savarts law, we reach up to one expression. That expression was dH equal to IDL cross AR cap divided by 4 pi r square. Now this same expression we can write in the form of B, that is flux density. We know the relation between H and B. What is that relation? B is equal to mu H. So if I have to write B in this place, what I have to do? I have to replace it with H equal to B by say mu. So if I want to write this expression for dB, so what I will write? dB is equal to nothing but mu H. So I have to multiply this term with mu. So I will get mu into IDL cross AR cap divided by 4 pi r square. Right. So whenever I say consider H and B same, that means we have to add mu also. That is default in the formula. Now today what is our important part? We will explore this expression and we will discuss what is this R square and AR cap. AR cap basically. Now AR cap is direction and R is the distance. Now let us again consider the standard case of our mobile phone and tower example. Suppose our current carrying conductor who is creating a magnetic field, we are considering as a antenna, and this antenna is present everywhere in the town and there are different points representing the mobile phones. Everywhere there are mobile phones and each point charge we are considering as a mobile phone, right? So what is this R square? This R square is the distance between the mobile phones, the distance between mobile phones and the antenna. Say, let us consider this distance is R1. Say this distance is R2. Now whenever I say mobile phone, you have to consider the test point charge. Whenever I say mobile antenna, you have to consider the current carrying conductor source. Now this current carrying conductor is of line shape. In next case we will see that current carrying conductor is a surface. In that case again we can consider the current carrying conductor is a volume. All of them are representing a source who is creating some effect in the surrounding region, and there are different radiuses. Say it may have some distance R3. Now R1, R2, R3 is nothing but this R, and this value is the magnitude. This value is the magnitude. Magnitude of what? Magnitude of the vector, position vector. This is very important topic. There will be one position vector, say r bar. The vector of position directly related with distance, its direction will be from source to destination. What will be the direction of this vector? Source to destination. So this is going from antenna to mobile phone. So this direction is like this, r bar. We can say it as r3 bar. Now what will be the vector here? r2 bar. This is magnitude, this is vector. Differentiate between that. Now third parameter, what is this vector? Vector is any vector r, either it is 1, 2, 3, 4, 5, whatever may be the number. It is equal to what? Magnitude into direction. What is it? Magnitude into direction. And what is the direction? AR cap. So magnitude and direction. So what is the direction here? This is going in some direction, x, y or z it may be. It may be ax cap, ay cap or az cap, or simply ax, ay or az. So this direction, say if it is going in x direction, I will say the direction is ax cap. So if I have this r bar as vector, this is very important. It will be product of magnitude of r into direction. What is this direction? In general we write it as AR cap, but it may be AX, AY or AZ. Or cylindrical system, it may be AR cap, A5 cap or AZ cap. So this is R bar basically, right? So what is there in our formula? In our formula there is one magnitude. Magnitude of R simply we are writing as R square here. And what is other parameter in our formula? AR cap. R bar is equal to mod of R into AR cap. From here, what we can say, what is AR cap equal to? Or simply AR equal to? We'll shift this term there. So what we can write? It will be R bar divided by mod of R or simply R. So can we keep this value of AR cap in our formula? Yes, we can keep. So what will be the modified formula we can say? We can further modify our formula. What is our formula? So we will write in the form of dB. dB is equal to mu IDL cross AR cap divided by 4 pi R square. This value we are replacing with this value. So what I can write? I can write for mu r equal to 1, what I can write here? Mu naught. What I will write? dB is equal to mu naught IDL cross R bar. What is this R bar? The position vector between the source and destination. Destination is point charge or mobile phone. Source is conductor or antenna. It may be line, conductor, surface or volume. Okay, divided by 4 pi. Already we have R square. We will multiply one more R. So what we will get? 4 pi R cube. Now this is another form of the magnetic field. This is flux density, but in interbooks it is also referred as magnetic field. So we can take this like this, take it like this also. So I hope this is clear. Now we will see magnetic field intensity due to one infinite long conductor. Now here we are saying that source. Whenever I say source, it is like antenna. Now I will consider one example of line charge density. That line charge density I will consider spreaded from say minus infinity to plus infinity, infinite long conductor, and what is its effect on surrounding region, and what will be the formula for magnetic field, that we will see now. So for that we have to consider one setup. We'll consider one axis, 3 axis. Say this is Z, now this is say Y, third one is X, right? So this is just a space, consider this is one space. Now in place of antenna, what I am placing, I have to place one conductor of infinite length. Say I will put it on Z axis. So Z axis I will put I will put one conductor, fine. So say this is the conductor. It is spreaded from, what are the limits for this conductor? Limit for this conductor, infinite long. So from Z, on Z axis, what will be the negative point here? What will be this value? Minus infinity. It is going towards minus infinity. What will be the upper limit? It is going towards positive infinity. Now this is nothing but our antenna. Now what I have to do, there may be so many different point charges like mobile phone, and I will consider one test charge and I will find out what is the value of this H or B, right? So for simplicity, if we consider some point in space, we have to consider the distance from X, Y and Z. So for simplicity, what we will do, we will consider the point is present on the floor. Now this classroom, suppose this classroom is example of this Cartesian coordinate system. So say that line is Z, the line below this board is Y, and the line coming towards you is X, okay, and the floor is one constant plane. So at floor we will get it easy. We will consider one point charge on the floor. Say my test charge or test mobile is on the floor. So on floor there will be some value of X and Y. What will be value of Z on this point? 0. On the floor height is 0 everywhere. So Z will be, for these coordinates will be X, Y, 0. Now what is my next task? I will consider small differential length on this infinite conductor. I will draw one line, the distance. What will be the direction of distance vector from source to destination? So it will be like this, R bar, right? And this will have some component here also, some angle. Now what coordinate system we will use? This is a conductor. Conductor is a shape of cylinder. So we have 3 types of coordinate system. One is Cartesian, one is cylindrical, third one is spherical. In Cartesian coordinate system, any point P we can represent by distance from X axis, Y axis or Z axis. In cylindrical coordinate system, we can find out the point with some radius. How much radius on the, suppose this is cylinder. On cylinder, how we can find out? Suppose you are in a cylindrical classroom. Suppose you are standing here and your position of head we want to find out the location. So first thing I will check what is the radius from the central line. Okay, I got radius. Then it is a circular position. So I will see what is the angle with reference to say this Y axis, right? Then I got angle phi. And how much height from your ground to up. So third point I will use Z, right? So like that we can find out the point P in the different position. So now what is our task here? We have to consider one infinite long conductor, and we will consider one test point charge on the floor, that is some surface and differential length. Now differential length dl bar, this is also vector. Now what is the vector? This vector, in which direction, on which axis this conductor is placed? Z direction. So this dl we can write as dz bar, right? Dz bar means magnitude of dz into direction in which side? Z side. So what will be this differential length now? Differential length we can write as dz az cap, right? So IDL is our formula. In place of dl, what we will write? dz az cap. Current is same, I current, right? Now what is our function? Our work is to find out R bar, AR cap. AR cap, if we are using this formula, we have to find out AR cap. By default, we will get these two values. So let us see this diagram in 3D also. Now this is what we are talking about, the diagram, and here this conductor is from minus infinity to plus infinity. Our test point is on floor. Now this system is cylindrical we are considering. So we are not considering the Cartesian. In Cartesian we get x, y, z. In cylindrical we get r, phi, z. So this is differential length on z axis, that is nothing but dz. Now dz, here this on this line, what will be value of x? X or radius on the central line. Now for simplicity we are extending the line. We are showing like a big cylinder, but actually it will be on x axis itself. So the point dl will also be on x axis itself. On x axis radius will be 0 on the same line, because from that line we start calculating. Okay, then there will be some angle phi, and of course there is some height dz, that is z. Point P we are considering on floor. On floor we will have some radius r, some angle phi, but height is 0. So these are the points. So one is source point, one is destination point, right? And we are talking about some r bar. What is direction of r bar? From source to destination. Very simple formula to calculate the position vector is that what we have to remember is r bar in any case R bar is nothing but destination points minus source point. What are the destination points? Destination points are, say, R, phi, 0. What are the source points? R, phi, sorry, these are same, R, phi, 0. What are the destination? Sorry, source points? 0, phi and z at this place, right? So now to calculate R bar, so what we will get here? We will write the position vector R bar will be equal to, say, first one. Who is destination? This is destination. This R minus 0. What we will get? R. What is that? This is magnitude. R bar is vector. R is magnitude. Its direction is AR cap. What is second point? Phi. Phi minus phi, 0. Then 0 minus z. So what we will get? Minus z into AZ cap. This is what? R bar, right? And from here, what will be the mod of R bar? How we calculate mod of r bar? We will take square root of the vector. What will be square root? Here we will get r square plus z square. If we multiply same vector with unit direction with same, it will become 1. So if we take it square, it will become 1. If we take it square, it will become 1. So it will be r square plus z square. So we have r bar, we have mod of r bar. So what will be ar cap equal to? What is direction equal to? Something divided by something. What is it? We have vector is equal to magnitude into direction. Hence direction will be equal to vector divided by magnitude. So we have, if we take this ratio, that is nothing but ar cap. So if this ratio will keep in the formula of BIOT-Savarts law, we have to put the limits, we have to solve it. So let us check it. Okay, so we reached up to ar cap. Ar cap is equal to r ar cap minus what? Z az cap. Z az cap divided by magnitude. What is it? Square root of r square plus z square. What is our basic formula? dH is equal to I dl into ar cap divided by 4 pi r square. In place of ar cap, we will keep this value. In place of dl, what we will write? dz az cap. So let us put these values. So dH bar will be equal to idz into, say this vector is also ar cap will be in z direction, az cap for this, divided by 4 pi. What is r square? R square 4 pi. This is r square into, this one will write r ar cap minus z az cap divided by square root of r square plus z square. Now here we have r square, one r square here, and we have one z term here. Now there is one more rule of a conductor. If we consider a conductor which is equally distributed on two sides. Say one we have at positive z, another one we have at negative z. Here we have positive charge, here we will have equal and opposite negative charge. So z component of this current will cancel each other. So only that numerator z term we can keep as 0. So what we will get here? So we can write it as, say dH equal to I dz by 4 pi. Now we have r square. R square is nothing but square root of, what is r bar? R bar is equal to, magnitude of r bar is equal to square root of r square minus z square. So two side we have, we can write r cube, but here we have square root at one side, so that value will be simplified as r square plus z squared by to the power 3 by 2. Here we will have r component r a phi cap. Now this is differential h. Now if we want to find out total h, what we have to do? We have to take the integration of the right hand side. So we'll take integration of this term I dz rho a phi cap by 4 pi in bracket r square plus z square to the power 3 by 2. Right. Now integration limits. What will be the limits? We have some limits, say for it's a line charge. Line charge means how many integration? Single. So and it is spreaded off on z axis. So what will be the limits? The limits will be from minus infinity to plus infinity. So we will apply some mathematics on that. We will simplify it. So what we will get after simplification of all the steps, we will get h bar is equal to I r a phi cap divided by 2 pi r, or what we can write in terms of b bar will be equal to mu I r divided by 2 pi r into direction. So now what is this value? This formula is for the magnetic flux density due to infinite long charge on some given point. Right? Here we can see it is inversely proportional to r, not r square. So like that we can consider various charge distribution. In second case we will consider say surface charge and volume charge. So with this we will stop this session here. Next cases of this magnetic flux density we will see in the next session. Thank you. Have a good day.